Hello, this is Sigma Bob. In this video, I will be discussing problems 6 through 10 from the AMC 10 2025A. We will carefully examine the problem statements, identify the key ideas required for the solutions, and work through the steps in clear and systematic ways. Let's get started. Here is problem 6 from the AMC 10 2025A. In an equilateral triangle, each interior angle is trisected by a pair of rays. The intersection of the interiors of the middle 20-degree angle at each vertex forms the interior of a convex hexagon. What is the degree measure of the smallest angle of this hexagon? This is a geometry and angle tracing problem. The key idea is to use the fact that each angle of an equilateral triangle is 60 degrees, so trisecting each angle creates several 20-degree angles. By analyzing the triangles and symmetry formed by these rays, we can determine the angles the hexagon created inside the triangle. Pause the video here if you'd like time to solve the problem yourself. Now, let's go through the solution. Each angle of the equilateral triangle is 60 degrees, and trisecting gives 20 degrees. Using any side of the triangle as a base, we can form an isosceles triangle with 20-degree angles. Since the sum of the interior angles of any triangle is 180 degrees, the third angle of this triangle is 140. One of the angles of the hexagon is 140 degrees, and by rotational symmetry, three of them are. The average angle in a hexagon should be 120, so the other three are 100 degrees each. So the final answer is C, 100. Here is problem 7 from the AMC 10 2025A. Suppose a and b are real numbers. When the polynomial x to the third power plus x to the second power plus ax plus b is divided by x minus 1, the remainder is 4. When the polynomial is divided by x minus 2, the remainder is 6. What is b minus a? This is an algebra problem involving the remainder theorem, where evaluating a polynomial at specific values gives information about its coefficients. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. Using the remainder theorem, plugging in 1 gives the equation a plus b equals 2. Plugging in 2 gives 2a plus b equals negative 6. Subtracting the first equation from the second gives a equals negative 8. Substituting back, we find b equals 10. Finally, b minus a is 10 minus negative 8, which equals 18. So the final answer is choice E, 18. Here is problem 8 from the AMC 10 2025A. Agnes writes the following 4 statements on a blank piece of paper. At least one of these statements is true, at least 2 of these statements are true, at least 2 of these statements are false, and at least one of these statements is false. Each statement is either true or false. How many false statements did Agnes write on the paper? This is a logic problem where you have to determine which statements can be true or false without causing a contradiction. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. If we assume the fourth statement, at least one of these statements is false or false, that would mean none are false, all 4 would be true. But if all 4 were true, then the fourth statement saying at least one is false would actually be telling the truth, which is a contradiction. So the fourth statement must be true. Since the fourth statement is true, there is at least one false statement. That means the first statement, at least one of these statements is true, must also be true because we already have at least one true statement, the fourth. If the first were false, then none of the statements would be true, which contradicts the fact that statement 4 is true. So statements 1 and 4 are true. Now, because at least 2 statements are true, the second statement, at least 2 of these statements are true, must also be true. That leaves only the third statement, at least 2 of these statements are false. Since we already know 3 statements are true, there can be at most one false statement, so the third statement is false. So the total number of false statements is 1. So the final answer is choice B, 1. Here is problem 9 from the AMC 10 2025A. Let fx equals 100x to the third power minus 300x to the second power plus 200x. For how many real numbers a does the graph of y equals fx minus a pass through the point 125? This is an algebra problem where we shift a cubic polynomial horizontally and count how many shifts make it go through a particular point. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. We want the graph of y equals fx minus a to pass through the point 125. This means we substitute x equals 1 into fx minus a and set it to equal 25. Substituting gives 100 times 1 minus a to the third power minus 300 in parentheses 1 minus a to the second power plus 200 1 minus a equals 25. Simplifying this equation leads to the cubic equation in A. A cubic equation with real coefficients can have at most 3 real roots. By analyzing the sign changes and applying the intermediate value theorem, we find that there are 3 real solutions for A that satisfy the equation. So the final answer is choice C, 3. Here is problem 10 from the AMC 10 2025A. A semicircle has diameter AB and chord CD of length 16 parallel to AB. A smaller semicircle with diameter on AB and tangent to CD is cut from the larger semicircle as shown below. What is the area of the resulting figure? This is a geometry problem involving semicircles, chords, and area subtraction. Pause the video here if you'd like time to solve the problem yourself. Let the radius of the larger semicircle be x and that of the smaller semicircle be r. We are looking for a half times pi times quantity x squared minus r squared. If we connect the center of the large semicircle to one endpoint of the chord and the center of the chord, we get a right triangle with lengths 8 and r with hypotenuse x. X squared equals r squared plus 8 squared, and that means x squared minus r squared equals 64. Plugging that in, we get 32 pi. So the final answer is C, 32 pi.